This is properties of logarithms, logarithmic functions. So the first thing that we have is called our product rule. Not to be confused when you get to calculus with your product rule there. So if I have a generic log base A m times n, they have a big m and n, times n, that can be converted to two separate logs, and we're just going to add them together. So then I would have log still with the same base of m plus log base A of n. So I add these together. So when I have multiplication inside, if I wanted to think about it like I had parentheses, you could think about it like that. They don't always have parentheses. So if I have some numbers in an example, if I have log with a base of 3 of 9 times 27. Okay, so what I'm going to do, there's a couple different ways I can do it. A lot of times, or not a lot of times, this one I would be able to actually multiply them together, but that doesn't use our product rule, so it's not a good example of how it would work. I can do log with a base of 3 of 9 plus the log base of 3, 27. So when I do that, I'm going to work down. I'm going to rewrite those. I'm going to rewrite 9 with a base of 3, so 3 squared. And 27 is 3 to the third power, so I'm going to write 3 cubed. And so then I have, that will equal 2 plus 3. And so my answer for that would just be 5. If I wanted to do that in my calculator as well, if I had 27 times 9, that would give me 243. So then if I wanted to find log base 3 of 243, and this is just kind of a check for things that you should already know that works. If I wanted to do 3 to some power, I should be able to do 3 to the 5th. Okay, because I just figured out that 5 would be that power. Okay, most of the time 243 is something really that it's kind of, we wouldn't have known that had we multiplied it, so it's easier for us to actually go through and break it down with smaller numbers, the 27 and the 9 that we should hopefully know, or you will learn at least. And then my next rule is the power rule. And these are all just rules for logarithms, so don't go around being like, I know the power rule. So my general format, I probably could have done another example for you for the other one too. So I will just give you an example, and then we'll do a couple of each of them. Whenever I have some exponent to some number, I can bring that exponent out front. And we've kind of already seen that working a little bit. But I will do p times the log of a base A of m. So an example of that will be, let's try to find one that actually works nice. I have log base A of 11 cubed. Okay, all I'm gonna do is rewrite it using this power rule. I have negative 3 times the log base A of 11. Okay, and an example of one of the ones that we did yesterday was we had log of 5 to the 4th with a base of 5. So what I'm going to do is bring that 4 out front. I have 4 times the log of 5 base 5. 5 base 5 is just 1. So then I'm just left with 4 times 1, which is 4. So that's kind of how you can use things to simplify it. That's really what's happening when we're able to just say 4. Let's use some different rules to rewrite things separately. So if I gave you a problem, we're going to use our product rule to rewrite this one. I have log, my stuff stopped working. I have log base 2. Okay, so to rewrite things, with the product rule that we just used before this one, if I have log base 2 of p cubed plus log of q base 2. Okay, to rewrite it as a product, I just rewrite my log base 2 one time, and then I multiply the things that I have out here. So I have a p cubed times q. And that's all I have to do to rewrite it. And a lot of the questions are just kind of wordy kind of stuff like that. It's not really like a lot of actual problems. Some of it is just seeing, can you rewrite it? Do you have what will be useful in a little bit to do this? Then I have, then if we wanted to rewrite a few things using the power rule, if I had log of a of the fourth root of 7, I have to go through and I'm going to work down. So I would kind of have, I would rewrite the fourth root as 7 to the 1/4. And then I'm going to bring that 1/4 out front. So I have 1/4 times the log of 7 base a. And so those are the product and power rules. Then we have the quotient rule. So what happens with the quotient rule in generic-y terms is the log with a base of a of m over n. And then where with products we added, here we'll subtract them. So we have to make sure that we're actually writing them in the correct order. So I have log of m base a minus log of n base a. So a quick example, if I had, that's not tog, how about log? Log base t of 8 over w. That will just look like log base t of 8 minus log base t of w. Okay, these are pretty weird to actually look at. Some of them are nice, some of them are not so nice. To go backwards with one, if you have log base b of 64 minus log base b of 16, I'm going to rewrite this back into a quotient from the subtraction problem. So then I'm going to rewrite log base b of 64 over 16. So whatever one is in front is then on top of my fraction. And then I'm going to rewrite this. 64 divided by 16 is 4. So I'm going to rewrite it as just log base b of 4. All right, now we're going to make a list of common errors that you don't get to make because they'll be mad if you do that. So common errors include doing if I had, so these are going to be all in generic-y terms. And this does not, log of m times n, does not mean log of m times the log of n. That's not what that means. The next one is saying the log of m plus n equals the log of am plus the log of an. These are really long to write out. I'm sorry about that. Log base a of m over n does not mean that I have log base a of m over log base a of n. This thing right here is called our change of base formula. This over here is not our change of base formula. So they're not equal to. And then I have log a m all to the p is not equal to p log a m. Okay, so you just have to remember some things that look so similar to each other. Um, because the reason why this one is mistaken every once in a while, or quite often, is because log A m to the p. So you have to realize. The reason why this is such a common mistake is because this does mean log base A. Those are why it's mistaken. These ones are just getting the rules mixed up. Okay, so now we're just going to rewrite a few of them that look really gross, and we're just going to rewrite them, and honestly, they don't really look any better, but they're less jumbled. So I have a log base A of x squared y to the fifth over z to the fourth. So let me find a space for my 4. So the first thing I kind of do is make sure that I realize that these two things are grouped together on top, because this fraction bar kind of makes that order of operations happen. So I'm going to do my quotient rule first. My pen is just not working good. And then I have log base A, and then I have x squared y to the fifth minus, because of the division piece, log, I still have to write that, so z to the fourth, so I'm subtracting that because it was a division. So now I get to separate these two multiplication pieces and do that with an addition sign. So then this guy goes down into log base A of x squared plus log base A y to the fifth minus log base A z to the fourth. Okay, it's a lot of writing, but it shouldn't be anything really crazy at all. So that's all you have to do to rewrite them. Let's do some ones where we're going to have to actually bring that exponent out front as well. So I have log base A of the cubed root of a squared b over c to the fifth. Okay, so I'm going to rewrite this. I don't like having a cubed root because I really can't see that as an exponent. So I rewrite everything that's inside. I'm getting really sloppy at my writing, I'm sorry. Over c to the fifth. Cubed root is really to the 1/3 power. So then I'm going to bring that 1/3 out front. So then I have 1/3 times the log base A of a squared times b over c to the fifth. And then I'm going to have a 1/3 out front of everything. And then I just realized that I forgot to do one more step on this top one, but we'll go back and do that in a second. So I have 1/3 out front of everything. My bottom piece is the division, so that's going to be the subtraction piece that I'm going to do first. So I have log base A of a squared b minus log base A of c to the fifth in parentheses. So everything I have the 1/3 out front. So he's just kind of hanging on out here. What's up? And then I rewrite this multiplication piece as an addition piece. So then I have log base A of a squared plus log base A of b minus log base A of c to the fifth. Now I have everything written like this. Now I have some exponents, and this is the piece that I forgot to do up here as well. So then I can rewrite this. I still have the 1/3 out front, and I'll use my distributive property at the end to do that. And I bring that 2 out front, so I have 2 times log base A of A plus, I don't have any exponent here, so I have log base A of B minus the 5, I bring that exponent out front, minus 5 times the log base A of C. And then I distribute this 3 throughout things. So I have 2/3 log base A of A is actually going to simplify to 1, so it'll just be 2/3 there. And then plus 1/3 log base A of B minus 5/3 log base A of C. Okay, so I'm gonna, whoops, I didn't mean to actually cross that out. I'm gonna go back up here and rewrite this one as well. So this 2, this exponent comes out front, so I have 2 times the log base A of x plus 5 times the log base A of y minus 4 log base A of z. I think it's a little bit easier to write the time symbol in there just for notation's sake so I don't get confused on where my log ends and begins and all the other junk. Sometimes you'll actually have to go the other direction though. So I have 5 times log base B of x minus log base B of y plus 1/4 log base B of z. So the first thing I'm going to do is rewrite these all as exponents. Okay, so I go through and rewrite them as exponents. I will have log base B of x to the 5th minus log base B y of y plus, instead of 1/4, I have log base B of z to the 1/4, which when we get to the end, we will rewrite that as the 4th root of z. Either way is acceptable though. Then I will rewrite it. I'm going to work from left to right. As soon as I have like no numbers out front, I can work from left to right. And then I will do log. I still have a base b. Subtraction, I was going to say minusing. Subtraction means division, so I'll have x to the 5th over y plus log base b of z to the 1/4. And then this means multiplication. If I were to actually just do that multiplication, all that's going to happen is I'm going to treat z like it's a fraction and z will be on top. So then I'll have log base b, so this was supposed to be a b over here, sorry that I wrote an a, of x to the 5th times z to the 1/4 over y. Okay, instead of 1/4, I could write the 4th root of z. It doesn't really matter. It's not a big deal at all. Then if I have another example is if I had the natural log of 3x plus 1 minus the natural log of 3x squared minus 5x minus 2. I'm going to do rewrite it with the quotient rule. So subtraction really means division. Okay, so the bigger one is going to be on bottom because it's the second piece. So then I have the natural log. I don't have to worry about writing any bases because it's a natural log. And I have 3x plus 1 over 3x squared minus 5x minus 2. In order to factor that, I take negative 2 times 3, and I get negative 6. Oops. And then I'm looking for what number multiplies to negative 6. That will add to negative 5. And that will have to be a positive and a negative number. So it will have to be negative 6 and positive 1. And that will give me negative 5. So when I rewrite this in order to factor it, I'm just going to work on this off to the side. I'll have 3x squared minus 6x plus 1x minus 2. So I get confused on what numbers I have to put in what place. So out of this first piece, I can factor out a 3x, and I will be left with an x minus 2. Out of this piece, I can't actually factor out anything. Since I can't factor out anything, I write plus 1, and I'm left with x minus 2. So I have 3x plus 1 times x minus 2. And then I'm going to rewrite that down here. I have natural log of 3x plus 1 on top over 3x plus 1 times x minus 2. Those guys get to cancel out. and I am just left with the natural log. When I actually cancel these out, don't forget that it's a 1, not a 0, so I have 1 over x minus 2. Okay, we've already kind of realized that log base a of a to the x equals x, but also realize, so this is called a logarithm of a base to a power, and then we have a base to a logarithmic power. So if I just had a to the power of log base a of x, that will also just equal x. So basically a base and the log piece kind of cancel each other out, even if it's, no matter how it's written, even though it's really sloppy to say, canceled out. Okay, and then I'm going to try to do this next example pretty quickly so I can try to get out of here. We'll see how this works. I am told, so in the instructions, you'll be told something that log base a of 2, does not matter at all what that log or what that base is 0, whoops, sorry. I'm going to use the numbers that they actually give me, 0.301. And I am also told that log of the same base a of 3 is equal to 0.477. Now I'm going to be asked to basically use these rules. I am asking you what log base a of 6 is. So what you have to decide is how 2 and 3, these numbers here, relate to 6. And you can say, oh, well, I know that that 2 times 3 is equal to 6. That's great. Now I'm going to use all my formulas that you know already. And I'm going to rewrite it. And then I'm going to say log base a of 2 plus log base a of 3. And then I'm just going to replace it with those numbers. So I have 0.301 plus 0.477. I don't have my calculator handy, so I'm going to let you guys just add those up and figure out what those answers are. Okay, you're going to do the same thing. What is log base a of 2/3? This is division happening here, so I will have log base a of 2 minus, I thought I was kind of skipping a step, and that's because I had to rewrite the multiplication one as 2 times 3. This one's already written in division. Okay, I will replace it with those numbers. I will have 0.301 minus 0.477. Okay, some of them are a little bit tricky because they will say log base a of 81. And you're just like, hey, I have no idea how I can get a 2 out of 81. And that's because you're not expected to. I'm going to rewrite 81 as, as 3 to the 4th power. Okay, you guys can play around and figure out what power it would have to be. This is an A, it's bugging me. So then I bring that 4 out front, and I have 4 times log base a of 3. I then take 4 times 0.477. Okay, so you're just going to have to rewrite things in all kinds of ways. And then I can do log base a of 5. Okay, so all the properties that we had to do with so far were with multiplication and division. So the tricky piece about this is that just because log base a, if I did 2 plus 3, I'm like, hey, 2 plus 3 is equal to 5. That doesn't work. We don't have any properties that tell us what to do with this. So we cannot do this one. I want you guys to do work on page 437, sorry. And I want you to do numbers 3 through 99 by 3s.